Hello, my name is Steve, and this is a short video to discuss problems that customers may encounter with ZMF users generating RACF pass tickets for use by Changeman ZMF. These issues would usually be encountered during the initial setup of ZMF pass ticket functionality. This video is not designed for pass ticket validation errors, so if you're seeing things like invalid password messages or anything like that, this is probably not the video for you. We will cover those issues in a separate video at a later date. So what sort of problems are we talking about here? This is my TSO user session, and I am looking at the ZMF server started task at this moment in time. It's actually this one here, it's a sub i6, and this is clearly running on LPAR S001. So if I switch now to my user's TSO session, you will see that he is actually logged on to LPAR S002. So this is a good scenario to test RACF pass ticket validation or generation issues, because any connection from this LPAR to our SIR6 ZMF subsystem will require the generation of a RACF pass ticket. What happens if this user currently tries to get into this ZMF subsystem? Well, let's give it a try. And this option 6 is pointing to our SIR6. When I hit enter, you'll see that they failed to access ZMF and that the pass ticket generation failed message is returned. Similarly, if we switch to a batch job that they've got set up, so this is a report, a standard ZMF CMN 990 report, global for global admin. You will see that we've got the JCL saved off so that they can submit it and run at will. I shouldn't mention before I submit it, this test palm is active here. This will be useful in diagnosis of problems at a later time, so we'll cover that in a minute. So if we run this job, and look at the output, it's already completed. You will see that the job has ended with a return code 8. And then if I look at the individual output files from that job, you'll see various connection failures in the sys print. And if I look at the SIR print, there is a whole host of information that I will cover now. Before going any further, I think it's important to explain the types of connection to a ZMF server started task that can be executed. I'm not going to go into details on either, but there are two primary connection methods. Those are cross-memory services and TCP/IP. Different utilities default to using different connection methods. What is important to realize is that cross-memory services can only work when the connection comes from the same LPAR that is hosting the ZMF server started task. So XMS will only work on the same LPAR. TCP/IP will work from any LPAR which shares DASD with the ZMF server started task. Also, in most situations, utilities will default to one connection method and automatically try the alternative connection method if the primary connection method fails. Some utilities also offer you a method of forcing a specific connection type. Other utilities do not. Again, not too important for the details of this video, but it is something to be aware of. A RACF pass ticket is only generated for mainframe-based TCP/IP connections. Obviously, that's important to realize. Regardless of where they originate, that can be from the same LPAR or a different LPAR. Cross-memory service connections do not generate pass tickets. Neither do client pack or ZMF web-based web service generated applications. Those all use user password validation to connect to the ZMF server started task. So pass tickets are not relevant for any of those connection types. As our report has executed SIR XML RC underneath the covers, this is actually a good mechanism to test RACF pass ticket generation issues, because a SIR XML RC always defaults to a TCP/IP connection type. Looking at this trace data, what is important here? On this first line, you will see the following. Notice that the connection method is T. This indicates that this is a TCP/IP connection request that is being executed. And if we move further down, you will see this information here. This is obviously the same error message that we saw when connecting to the ZMF server started task through the ISPF interface. So our PassTicket generation has failed. So as mentioned before, SerxMRC immediately changes tack and attempts to execute cross-memory services connection, method equals X. Because this user is running on S002 and our ZMF server started task is running on LPAR S001, again, this will fail because cross-memory services connections cannot work across LPAR. Okay, so how do we go about checking and diagnosing this problem and hopefully resolving it? The first thing to check is that everything is running on the exact LPAR that you expect it to. So one problem we frequently see in the support team is where customers have unexpectedly had a job run on an LPAR that obviously they did not expect. So let's take a look at an example of what we can check there. So here's a job that user CMN sub0 ran earlier. Obviously we can see it was submitted on the S001 LPAR. So obviously it ran there, yes? Well, no. The most important message in this situation is that $#373 message. Because this job actually had a job palm routing it out to the S002 LPAR, although the job was actually originally submitted on S001, it actually ran on S002. That's a frequent problem we see with customer reports where basically a job executed on an LPAR they did not expect. This is obviously a 132 by 27 display we're looking at here. So if I switch columns on, you can see column 80 comes to here, and users running on a 24 by 80 screen might not even see this section of the #373 message. So that's always a good thing to check that the job has actually executed on the LPAR that you expect. Even if you have no job palm sysaf cards or root execute cards, with the workload balancing and the workload manager now in operation just about everywhere, jobs can be routed around many different LPARs without users really knowing or realizing that that's actually occurring. That's the first thing to check. Okay, this has run on the LPAR that I expected. So what's the next thing? Well, that kind of depends on what's happened in the past. The first thing to really go through is, has any user ever successfully connected to a ZMF subsystem from this client LPAR? If so, does this LPAR host a ZMF 8.1 server started task of its own? And has that 8.1 plus task been started since this LPAR was last IPL'd? If this client LPAR does not host a ZMF 8.1 plus server started task, or if it has not been started since the last IPL, then has the SerSet job been run? The SerSet job actually copies the executable SerxPTIC from the product executable libraries into CSA, and this module is called whenever a mainframe-based client attempts to connect to a ZMF server. Starting a ZMF 8.1 plus server started task on an LPAR will implicitly execute the SerSet functionality and copy SerxPTIC to CSA. If SerxPTIC is not resident in CSA, then attempts to generate a PassTicket for use by ZMF will always fail. How can we actually check if SerxPTIC has been copied to CSA? Well, let's go up here and type TSO ISRDDN. So you can execute this command anywhere from within ISPF. And if we just do a simple browse SerxPTIC, you will see that this module has been found and it resides in CSA. Okay. So if, for example, we browse a non-existent module, so nexist, you will see an error such as this, module not loaded. So that's the best check to see if SerxPTIC has been loaded to CSA. If it's in CSA, then we move on to the next step of diagnosis. If not, either start your ZMF 8.1 plus server started task or execute the SIRSET routine for this LPAR. At this point, we have to move on to your RACF administrator for further diagnosis. So let's swap back to my screen where I am actually the RACF administrator. Let's start looking at RACF commands that you might find useful. I've stored all these in jobs just for ease of demonstration. Obviously, any of these commands can just be executed using a standard TSO command by a suitably authorized RACF administrator. Let's go into a list. So 2 commands here. The first will list the contents of the SIRNet profile within the PassTicket data class. And the second will simply list the RACF options active on this for this RACF database. So if we submit that, and we can then go off and look at the output. Okay, so let's just look at this output. Okay, let's take these in reverse order. Okay, so let's look at the second output first. The first thing to check is whether the PassTicket data class is active within this RACF database. And here we can see within active classes that the PassTicket data class is indeed active. If it were not active, you would need to go off and activate that class, and the command is included in both the standard documentation and also in the KV article referenced earlier. Okay, so that's good, but obviously what is not good is the response to the first command. I'll list the SIRNet profile within the PassTicket data class. This has not been found, so this is almost certainly at the root of our problem. So how do we go around defining it? Okay, if I swap back to my edit session, and instead of there, let's go to RADEFDE. So again, these commands can be executed just for a standard TSO command, but just for ease of demonstration, I'll put them into a batch job. Okay, so the first command there obviously deletes the SIRNet profile from the PassTicket data class. As we don't have one, that's slightly unnecessary for our purposes, but it's probably just a good thing to do anyway, just to ensure that everything's cleaned up before we go around trying to redefine the profile. Our second command just refreshes the contents of the PassTicket data class. Then we come onto our actual SIRNet PassTicket data profile define statement. So our define in the PassTicket data class, the SIRNet profile, single sign-on with the key masked encryption key. Now, obviously, use something more secure than the one I have here. In the past, some customers have questioned whether or not case of any of the hexadecimal characters here is important. Personally, even though we run in a case-sensitive RACF environment here, we've never noticed any problems around case. But just to err on the side of caution, I'd encourage you to use uppercase hexadecimal characters if you are included them in your encryption key. The other thing to mention is Apple Data no replay protection. This clause has to be specified exactly as seen here. It's very important to ZMF that this is specified. The architecture of the product means that it must be specified. Otherwise, you will see problems at a later date during RACF PassTicket validation processing. So very, very, very important. And again, the final command just refreshes the contents of the PassTicket data class to make sure that our new profile is activated. So let's go ahead and execute that. And go off and make sure everything executed okay there. Yeah. Guaranteed. Job always ends when you go looking for it. And if we scroll all the way down there, our initial delete failed, obviously because the SIRNet class was not there. The refresh worked fine. The second command, the define of the CERNet profile within the PassTicket data class, has executed successfully, and the refresh has run okay. Now, if I swap back to the user session and come out of that, if they try and access the ZMF service task, choose option 6. Obviously, the user can now access ZMF, having successfully generated and validated the PassTicket on the connection processing. Similarly, if they rerun their report job to run on the remote LPART, it has indeed completed. Okay, still a return code 8, but for different reasons, as you will see here when we look at the serprint output. Again, we've attempted to connect with a TCP/IP connection, and as you can see, everything's worked okay here. There's no errors, and we have gone on to actually execute all the services that are being processed by the report. And if we swap back to my user ID and look at the starter task output, and scroll all the way down there, you will see all the successful TCP/IP connections coming in and being detached for user CMN Sub-0. So hopefully that provides a very simple overview and a troubleshooting guide to the initial setup configuration and a validation of PassTicket generation errors. So a few caveats. All these tests were executed across 2 LPARs that share a single RACF database. If you're running on LPARs that do not share a RACF database, then the configuration and diagnostics steps should be identical, but you will need to execute the steps twice, once on each database. You will also need to define the same encryption key with a CERNet PassTicket profile in both databases. Very important that. And also, as an IBM limitation, even with a shared RACF database, when any PassTicket is generated on one LPAR and validated on another LPAR, the 2 LPARs must have their UTCs within plus or minus 10 minutes of each other. If they are not, the RACF validation of the generated PassTicket will fail. You can check the UTC time using a display T or a DT operator command. For example, okay, and you can see the UTC over there. Hopefully this all helps, and I am now off to redefine my CERNet PassTicket profile with slightly more secure encryption key than the one used in this demonstration. Again, for further reading, JCL and diagnosis purposes, please take a look at KB article S142191 on the support line website. And if problems persist, open an incident with customer support and we will be happy to try and help. Again, KB article S142191 contains a list of diagnostics that we would like to see to progress investigation. Thanks very much for listening. Talk soon.